Viscosity is a measure of a fluid's resistance to flow. This means that some fluids will flow faster than others. If a fluid is less viscous, it is more able to flow. Here we see that a fluid being dropped from above is easily flowing over the sides of the pan. This means there is less resistance to flow. Due to this, more of the fluid is able to flow over the sides of the pan. If a fluid is more viscous, it is less able to flow. Here we see that a fluid is not flowing over the high sides of the pan very much. This means there is more resistance to the fluid's flow, and less fluid will flow over the sides. Now let's head to the kitchen to see what low and high viscosity fluids actually look like. Here we have two glasses, one containing milk, the other containing honey. As bubbles are blown in the glasses, watch carefully and look at the movement of the bubbles. As you can see, the bubbles in the milk flow up and pop at the surface quite fast, whereas the bubbles in the honey flow up much slower and look goopy. But why is there a difference in the movement of bubbles? Viscosity, of course. We know that either milk or honey is more viscous, but which is? Since the bubbles move much more slowly through honey than milk, we can say that honey is better at resisting flow than milk is. Therefore, honey is more viscous than milk. But what happened here on the molecular level? Intermolecular forces are what affect viscosity. If a fluid is less viscous, like milk, there will be weak intermolecular forces and fewer bonds. If a fluid is more viscous, like honey, there will be strong intermolecular forces and more bonds. Now think about what is happening on the molecular level as we move a straw through our glasses of milk and honey. Since milk has low viscosity, I can overcome the intermolecular forces and move the straw around easily. Since honey has high viscosity, I cannot overcome the intermolecular forces as easily, so I feel a greater resistance as I move the straw around. Now let's look at a type of viscosity called kinematic viscosity. This is a fluid's resistance to flow under the influence of gravity. Think of it as pouring water from a bottle versus pouring maple syrup from a bottle. What's the difference when you pour these? Now let's head back to the kitchen and investigate kinematic viscosity of milk and honey. Here we have drops of milk and honey on a pan. What will happen when I lift the top of the pan? Due to the low kinematic viscosity of milk, the milk races down the pan. Finally, honey starts moving down the pan. Its slow movement is due to its high kinematic viscosity. Now here's an interesting thought. What happens to the viscosity of a fluid if it's at a higher temperature? Try to identify which glass of honey is at a higher temperature. Here's a hint. High temperatures cause molecules to speed up in liquids, which causes a decrease in intermolecular forces. Do you remember what weak intermolecular forces mean in terms of viscosity? Which glass of honey was at a higher temperature? Clearly, the honey on the left has low viscosity. It moves like milk as the straw swirls around. As this honey was heated up in the microwave, the temperature increase caused the intermolecular forces to decrease. This results in a low viscosity liquid. Comparing the movement of the high temperature honey to the room temperature honey, it is clear that the temperature has a great impact on viscosity. Viscosity is an important property of fluids in the chemical and chemical engineering worlds. But as you go about your daily life, think about the viscosity of fluids you encounter. Is the water flowing out of the kitchen sink a high or low viscosity fluid? What about the syrup you put on your pancakes?